Find the area under the function on the given interval using the limit definition. Here the function is f of x equals x minus 4, and we're looking on the interval 3 to 8. The first thing we need to do is set up a limit as n goes to infinity. Now remember, as we go through and figure out this limit, n is the number of rectangles that we want in our area. So we're trying to make the number of rectangles as big as possible with this n going to infinity. From here, we're going to be looking at a sum of a function, and this is how we get the height of each rectangle. We want to start at 3, and we want to add 5 over ni. This ends up being the left side of the interval times the width of the rectangle, and when we sum I from 1 to n, what that tells us is that first we're going to jump over a little bit to the right endpoint of the first rectangle. Then when I becomes 2, we will jump to the right of the second rectangle. And this is how we get the height of each rectangle. So this f value here, this function value, will be the height of each rectangle. But if you're trying to find the area of a rectangle, you also need a width of a rectangle. And that just ends up being 5 over n. This is the width of the interval divided by how many rectangles you want in that interval. So from here, figuring this out, we need to actually do some scratch work. So I'm going to do this in red. F of 3 plus 5 over ni. We need to figure out what this is. So in order to do that, we're going to look back up here at the function. X gets replaced with this expression, so this x will also get replaced with that expression. Plus 5 over ni minus 4. And when this gets simplified, this turns into 5 over ni minus 1. So this value here is f of 3 plus 5 over ni. So this will get replaced by this. So now we have a limit as n goes to infinity of the sum as I goes from 1 to n of 5 over ni minus 1 times 5 over n. So when you are trying to compute the sum of something, we need to first make sure that the multiplication is happening. So the next step is to distribute this 5n. So this becomes the limit as n approaches infinity of the sum as I goes from 1 to n of 5 squared over n squared I plus, minus 5 over n. And then the last step for this page, I'm going to separate out this entire sum. So one thing that is important to remember is that 5 squared is a constant, it's 25. I will write 25 in the next step here. But n is also a constant. So we treat 5 and n as a constant. So when you're looking at this next step, this is the limit as n goes to infinity of these let's see, of the 25 over n squared, the sum as I goes from 1 to n of I minus, when you are trying to sum up a constant, you have to just multiply the upper bound times the constant. So n times 5 over n is just 5. From the previous page, this was the last thing written. The only thing we need to do now is simplify this summation. And in order to simplify that summation, I'm just going to write it off to the right here. The summation as I ranges from 1 to n of I is equal to n times n plus 1 over 2. So this will go in place of that blue box right there. So we can rewrite the limit as n approaches infinity of 25 over n squared times this sum over here. This is n times n plus 1 over 2 minus 5. And from here, all we have to do is simplify as best we can and then take the limit as n goes to infinity. The only simplification that I see is there's an n squared in the denominator and an n in the numerator. So I can cancel that. That looks like it leaves us with a limit as n approaches infinity of 25 over 2, and there's still this n plus 1 in the numerator, and there's still this n left over in the denominator. And from that, we're going to subtract 5. The only thing left to do is to find this limit. So the easier term is back here, this negative 5. The limit as n goes to infinity of a constant is just a constant. So that is negative 5. But this first term, you may have to think back for this. The limit as n goes to infinity, this feels like we're trying to find a horizontal asymptote. And since the degree of n in the numerator is equal to the degree of n in the denominator, they're both 1, we take the ratio of the leading coefficients. So the 25 times 2, or 25 over 2 comes along for the ride, and the limit as this thing, of this thing as n goes to infinity is 1. So when you have 25 over 2 and you're subtracting 5, you will get a whopping 15 over 2 units squared. There is the area underneath the curve of that graph. And one really quick idea here. What do we mean when we say area under a curve? So if you were to see a picture of this actual function, you would know that the graph would go through the point 3 comma negative 1, and that's if you go back and look at the actual f of x equals x minus 4. If you substitute 3 in here, you're going to get back negative 1 for your y value. And similarly, if you substitute 8 in there, you will get back 4 for your y value. And this is a linear function, so I'm going to try to do that there. What we mean in mathematics by area under a curve is the area between a curve or your function and the x-axis. So something there and something like this here. We have all of this area that we're trying to find. So you just quickly analyzing this, we know that this triangle is 4 high and this blue triangle is also 4 wide, and that this triangle over here, this red one, is 1 high and 1 wide. And so the area of the blue triangle is, what, 8 square units? And the area of the red triangle is 1/2 a square unit. Oops. But if you add these areas together, you get 17/2 units squared, which is strange because we got an answer, all the math is correct, we got an answer that is 15/2 units squared. Well, what ends up being the case is that any time you're finding an area above the x-axis, this is a positive area. It ends up being a positive area. And then we get into some very shaky ground in the real world, but mathematically not so shaky. When you have an area that happens underneath the x-axis, this ends up being a negative area. And again, practically in the real world, negative area doesn't make any sense, but in mathematics it does. And that's how we get this answer of 15/2, is we have an area of 8 square units, and we take away what's underneath the x-axis. We take away 1/2 a unit, that leaves you with 15/2 square units.